Hello guys, good morning and welcome to my first virtual physics class for 10th grade that is about kinematics. Now to start we're going to do a review about average velocity. That was the first word problem that we did in physics. Now this is the second one in order for you to be, to warm up as a warm-up activity. Now it says a doctor travels to the east. From city A to city B, there are 75 kilometers in 1 hour. What is the doctor's average velocity? Now, to start doing the problem, first we need to see the equation. This is the equation that we use for average velocity. Average velocity equals change in displacement, or change in position, divided by change in time. Change in position is what we call displacement. Remember the exercises or the time that I was running inside a classroom just to show you the difference between distance and displacement. Now, to calculate the average velocity, we need displacement and we need time. Now, take a look at the problem. In this problem, there are given a direction over here that it says to the east. It is also given 75 kilometers. Now, 75 kilometers, and we talk about city A and city B, so we're going to say this is what we have. Okay, now between the two cities, we have 75 kilometers. This is a 7. Okay, now between the two cities what we have is a displacement. This will be our delta x for this problem. Now, in how much time does the doctor does all the trip? It does it in 1 hour. So this is a given that we know as time, of course. So first of all, what we do in a physics problem is to start writing the givens. So we already said that as I have a city A and B, the distance between the two is going to be our displacement. Now, the second given of the problem is the time. How much does it take? How much does the doctor take to travel from city A to city B, from San Pedro to Tegucigalpa, for example? So we say delta t, or time, is 1 hour. Now, what is the doctor's average velocity? This is the unknown. So we say average velocity, v, avg, equals unknown. Oh my god, we don't know. We're going to find out. Now, let's see. This is the equation that we need. And these are the givens. We have everything that we need. But remember I told you, from first day probably, if we measure displacement, we're going to talk about length. If we talk about length, the SI unit that we use to measure length is meter. So from kilometers to meters, we're going to do a conversion. Now, the SI unit that we use to measure time is not hour, it is the second. So first of all, what we're going to do is a conversion from kilometers to meters and from hours to second. So remember, in 1 kilometer, there are 1 times 10 to the third power meters. This is in the page 12. Remember that table that you just learned. Now, in 1 hour, we know there are 3,600 seconds. So when you do the conversion, if you don't remember, I'm going to do the conversion here. So it's going to be 75 kilometers times. In 1 kilometer, I have 1 times 10 to the third power meters. And I cancel the units because they are in opposite direction. This is in the top and this is in the bottom, so the units are canceled. So the final answer will be 75,000 meters. Remember to keep close to you your calculator. Now the second conversion is 1 hour to seconds. We know the conversion factor between hour and seconds is, in 1 hour I have 3,600 seconds. Hours and hours are in opposite directions, so we cancel and we say 1 times 360 divided by 1, 3,600 divided by 1 is going to give you the same number, 3,600 seconds. Now, can we find the average velocity? Of course. So we say, we start to solve the problem, and we say average velocity equals delta x divided by delta t. This is equal to 75,000 meters divided by 3,600 seconds. We use the calculator. We use the calculator here, and we say 75,000 divided by 3,600 seconds. So our answer is 20.833333. We rounded in 83. And the units are meters in the top, second below. Meters per second. And as this is our final answer, we don't forget that we need to box our answer. Now, for the second problem, we have average acceleration. A shuttle bus slows down with an average acceleration of negative 1.8 meters per square second. How long does it take the bus to slow from 9 meters per second to a complete stop? Now, from this word problem, to move a little bit. Okay, from this word problem, we need to first take the givens. Now, for average acceleration, what are the givens that I need? Here in hand I have the equation for average acceleration. This is, we need average acceleration equal change in velocity divided by change in time. Now, what is change in velocity? Final velocity minus initial velocity. Okay? So, we start by writing the givens. We need delta V. Delta V equals V final minus V initial. Which one is the initial velocity? Let's read the problem again. It says to slow from 9 meters per second to a complete stop. What does it mean? The bus was traveling at 9 meters per second, and at the end the bus stopped. So as it is stopping, is not moving. So first it was 9 and then it is completely stopped. So we said that the initial velocity was 9 meters per second, and the final velocity, as it says to a complete stop, we assume that the final velocity is 0 meters per second. Now, what is the other given that the problem is telling us? It says the bus slows down with an acceleration, average acceleration of, so we write the acceleration. Average acceleration equals negative 1.8 meters per square seconds, meters per second squared, sorry. So as you can see, we don't forget to write the symbol. Now, how do we solve this problem? First of all, we write the formula. Acceleration, average acceleration equals delta V divided by delta T. We know that delta means change. So we say final velocity minus initial velocity divided, we don't have the time, so we are looking for the time. Sorry, I kind of forgot to write it. So delta t is unknown. Why? Because it's the question, okay? It says how long does it take? How long does it take? How long does it take to eat your breakfast? It takes around 20 minutes. How long does it take the bus to slow from 9 meters per second to a complete stop? We don't know. So delta t is the unknown. And the average acceleration, we know it, is negative 1.8 meters per second square. So the equation to find delta time or change in time or that time, doesn't matter how you say it, it's delta t equals final velocity minus initial velocity divided by average acceleration. This is the equation already isolated for time. Now, final velocity is 0 meters per second minus initial velocity is 9 meters per second. All this divided by average acceleration, which is negative 1.8 meters per second square. 0 minus 9 is negative 9 meters per second divided by negative 1.8 meters per second square. When you divide all this, will give you 9 divided by 1.8, negative 9 divided by negative 1.8, 5 positive. 5, as we're looking for the time, we know it's seconds. And why is that? Because meters and meters are going to be cancelled. And 1 second here with 1 second in the other side. Remember, second square is second times second, so you're canceling just 1 second. At the end, you're going to have your answer seconds in the top. If you have a question how I did this, I'm going to do it right now because I kind of like you and I want you to understand. Okay, so you have meters per second in the top divided by meters per second square. We have here what we call a sandwich. Those that are in the top and in the bottom are going to be multiplied in the top, meters and second to the second power, and these that are in the middle are going to be below, seconds times meters. So this one and this one is going to be cancelled, and in the top you will have seconds to the second power divided by seconds. This is the same as having seconds times seconds divided by seconds. Cancel. And at the end, your answer is seconds, just as we have over here. That's how you get the unit. Remember, you can stop the video as many times as you want. Okay, guys, thank you for watching, and in the other video, I will explain the other two examples. Okay? See you later. Well, talk to you later.